Hello, my students, and welcome to this recorded session. In this session, we are going to talk about rectilinear motion with uniformly accelerated. And before we start, I want to define the acceleration. What is the acceleration? The acceleration is the change in velocity with respect to time. So the acceleration A is the change in velocity with respect to time. So A equals V2 minus V1 over T2 minus T1. The acceleration, once again, it's the change in velocity with respect to time. What are the kinds of motion? Actually, we have three types of motion. The first type is uniform motion. The second type is uniformly accelerated motion. And the third type is non-uniform motion. What is the uniform motion? In uniform motion, an object moves with a constant speed in a straight line. The object moves with a constant speed in a straight line. That means the object covers equal distances in equal intervals of time. The object covers equal distances in equal intervals of time. Secondly, uniformly accelerated motion. What is the uniformly accelerated motion? Uniformly accelerated motion occurs when an object moves in a straight line and its speed changes at a constant rate. Its speed changes at a constant rate. This means the object's velocity increases or decreases by the same amount. The velocity increases or decreases by the same amount. So the uniformly accelerated motion, in the uniformly accelerated motion, the object moves in a straight line and its speed changes at a constant rate. And this means the object's velocity increases or decreases by the same amount over equal intervals of time. The third type is non-uniform motion. The non-uniform motion refers to the motion of an object where its speed changes regularly over time. And in this type of motion, the object doesn't cover equal distances in equal intervals of time. That's it. If we looked at velocity time graph in the first one, we have a relation between velocity and time. We observe that the velocity increases with respect to time. And if we are going to find the slope of this straight line, the slope is the change in velocity over the change in time, you will get a constant acceleration. So acceleration is constant and the acceleration here is positive. So the motion is uniform with a positive acceleration. In the second graph, we have a relation between velocity and time. If we are going to find the change in velocity over the change in time, okay, so the change in velocity over the change in time gives us the acceleration, and the acceleration here in this case is negative number or negative constant number. And the motion here is uniform with a negative acceleration. And the third graph, the relation here is between velocity and time. And as you see here, if we are going to find the slope of this straight line, the slope, because this line is parallel to x-axis, so the slope, and the slope in this case, the change in velocity over the change in time, refers to acceleration, and the acceleration here in this case is 0. So the motion is uniform and the acceleration is equal to 0. The displacement is the initial velocity, V naught, and the final velocity, V only without this symbol here. So the difference between them in this small dot here, V initial or V naught, and the acceleration is A and the time is T. You know, the acceleration is the change in velocity over the change in time or the time taken. So acceleration is equal to V minus V naught or V initial over time. We can do cross multiplying. So V minus V initial equals AT. We can add V initial to both sides or move it to the next side. So you will end up with V initial, V final is equal to V initial plus AT. And this is the first equation we are going to use in solving problems. So V initial, V final equals V initial plus A multiplied by time taken. The displacement S is given by the mean velocity, multiplied by time. What is the meaning of mean velocity? The mean velocity is the average of the velocity. So the mean velocity is V final plus V initial over 2 multiplied by T. So S is equal to V final plus V initial over 2 multiplied by T. And you know that V is equal to V initial plus AT. So we're going to substitute here in this equation. So S is equal to, instead of V final, I'm going to write V initial plus AT, V initial plus AT plus V initial, all divided by 2, multiplied by the time taken. So expand. And before expanding, we can tidy it up. V initial plus V initial is equal to 2V initial plus AT over 2 multiplied by T. Multiply T by all terms of the expression here. So T multiplied by 2V initial is equal to 2V initial T plus T multiplied by AT is equal to AT to the power of 2, all divided by 2. Here we have the expression divided by 2, so we can divide all terms of this expression by 2. So it will be 2V initial T divided by 2 plus AT squared divided by 2. We can write it as half. Cancel 2 and 2. So S is equal to V initial T plus half AT squared. So S is the displacement is equal to V initial T plus half AT squared. That's it. And also we use this rule in solving problems. If we have one of these, if we want to find one of these variables, which are S, the initial, T, and acceleration. So if we have the initial and we have time and we have acceleration, we can find the displacement. The displacement S equals V initial T plus half AT squared. You know that S, the displacement, is equal to V final plus V initial over 2, which is defined as the mean velocity multiplied by the time taken. And we know that V final equals V initial plus AT. I wanna make T the subject. So move V initial to the next side. It will be V minus V initial equals AT. Then divide by A both sides. So T will be equal to V final minus V initial over A. That's T. T equals V final minus V initial over A. Substituting this equation, S equals V plus V final over 2 multiplied by T, which is V final minus V initial over A. And then multiply. We have at the top, we have V plus V initial, V final plus V initial, and here V final minus V initial. It's difference between two squares. So when multiplying them, you are going to get V squared minus V naught squared over 2A. Then do cross multiplying. So V initial, V final squared minus V initial squared equals 2AS. Move minus V initial squared to the next side. So V squared, V final squared is equal to V initial squared plus 2AS. And we use this rule if we have V initial and we have the acceleration, we have the displacement, and we want to find the V final. So V final squared is equal to V initial squared plus 2AS. You know that displacement S is equal to V initial plus V final over 2, which is the mean velocity multiplied by the time taken. And this rule is a key rule. We use it to reduce the other rules. You know, V final is V initial plus AT. So V initial here, we can find it. If we move this to the next side, we would get V final minus AT. So we are going to substitute here instead of V initial in this equation, V initial. So S equals, instead of V initial, write V minus AT, and write plus V over 2, multiplied by T. So S equals V plus V, which is 2V at the top, minus AT, all divided by 2, then multiply by T. Expand this T by multiplying it in all terms here. So S equals 2VT minus AT squared, all divided by 2. Then S equals 2VT divided by 2. Okay, all terms of the expression here are divided by 2. So 2VT divided by 2 minus AT squared divided by 2. So S equals 2 and 2, 1 cancel another out. So you will end up with V final T minus AT squared divided by 2, which is half AT squared. That's it. So we have 4 rules that we use in finding any of the unknowns, like V final, V initial, acceleration, displacement, or the time taken. I hope you enjoyed this session, and I encourage you to do some practice on this area, and see you in the coming episodes. Goodbye.